This is some simple Chapel code, and we're going to go through some examples on two different types of machines. So this first one is a single node with a single AMD GPU. And then we're going to take the exact same code and go run it on a a one node with 4 NVIDIA GPUs. So starting out here, I'm just going to walk through some of this Chapel code. This is not a Chapel tutorial, so we're just going to talk at a very high level about some of these concepts. A couple of important things here. These config constants are going to let us control how the program runs from the command line. This all gets handled automatically for us by the compiler. Kind of the most important part here is which compute node we're going to compute on. So we're going to query our current locale and then look at all of the sublocales that it has. And if we have any sublocales, then we can use the first sublocale here. So that first sublocale will be our target locale. And if we don't have any sublocales, we'll just use the here. So in a much higher level, this is either using a GPU or using the CPU. We can then use that target locale and declare our array on the target locale. So now if target locale is a GPU, we have declared array in GPU memory, and otherwise we've just declared it on the CPU. We can then move computation to where that array is declared and start executing kernels. So there's a number of different ways we can execute kernels, but I think it's more fun to just see it happen in real time. So I've compiled this for an AMD GPU already. And if I run it with verbose GPU and print, we can see what happens. So we'll see, first of all, there's a kernel launch on line 21. And if I go to line 21, that's this parallel loop over the elements in the array, and we're just assigning the elements to the array. There's then another kernel launch on line 25. And this does not look like a loop or a kernel of any kind. But what's happening under the hood is the Chapel compiler is turning this nice array syntax into a parallel loop that is then GPU eligible to be launched as a kernel. So this program has 2 kernel launches, and then of course we can dump out all of our values. It's not very interesting because we're just initializing and incrementing. And of course, we can adjust the size of this problem and print lots more numbers.